Ever see a winter forecast that says rain, freezing rain, sleet, and snow and think, okay, but what does that actually mean for my driveway and the roads? Here's the crazy part. What invisible layer of air between you and the cloud decides whether you get plain rain, fluffy snow, crunchy sleet, or dangerous freezing rain? And a difference of just 1 or 2 degrees can change 10 inches of snow into 1 inch of cold rain. Today on Untamed Skies, I'll show you exactly how rain, snow, sleet, and freezing rain form, and how to read a winter forecast like a pro. If you love clear, no hype weather explainers, tap subscribe now so you don't miss the next video in this winter weather series. One general fact about our atmosphere is this: the higher up you go, the colder it gets. That cooling with height has a name, the adiabatic lapse rate, and we'll dive deep into that in a future video. For now, you just need to know that on average, air cools as you go higher. Because of that, in mid-latitude regions during the winter, the precipitation forming up at cloud level almost always starts out as snow. So the big question becomes, if it usually starts as snow, why do we sometimes feel rain, sleet, or freezing rain at the ground? The answer is the temperature of the air in the layer between the cloud base and you. To keep things simple in this video, air that is below 32 degrees Fahrenheit I'll call cold air. Air that is above 32 degrees Fahrenheit I'll call warm air. That's it. Everything about winter precipitation type comes down to how thick the warm layer is and where it sits. Let's check out this first scenario. If the warm layer above 32 degrees Fahrenheit is deep, extending from near the cloud base all the way down to the ground, the snowflakes that form in the cloud fully melt into raindrops and stay liquid all the way down. What you feel at the surface is plain rain. It might be chilly and miserable, but it's still just rain, not freezing rain. Now, let's tweak that setup. Imagine a warm layer aloft that still melts the snow into rain, but near the ground, there's a shallow wedge of cold air where the temperature is just below freezing. In this case, snow falls from the cloud into the warm layer. It melts into rain in that warm layer. Then as those raindrops fall through the shallow cold layer near the surface, the air is below freezing, but the drops don't have time to refreeze in the air. So they're still liquid when they hit the ground, but the ground and objects like roads, trees, and power lines are below freezing. So the raindrops freeze on contact. That's freezing rain. Liquid while it's falling, ice the instant it hits a surface that's below freezing. Freezing rain is extremely dangerous for travel and infrastructure. Even a thin, almost invisible glaze of ice can cause major problems on roadways and weigh down trees and power lines. Now, shrink that warm layer a bit more. This time the warm layer is shallower and the cold layer near the ground is deeper. Here's what happens. Snow falls from the cloud, it briefly melts into rain in the shallow warm layer, then it falls through a deeper layer of below freezing air before reaching the ground. Now the raindrops have enough time to refreeze in the air into little balls of ice. These ice pellets hit the ground and often bounce. That's what we call sleet. So if you've ever looked outside and thought, is it raining tiny ice balls? Yes, that's sleet. Now, for our last scenario, if the warm layer disappears entirely, so the whole column of air from the cloud to the ground is below freezing, then the precipitation stays snow all the way down. The snow forms in the cloud, it follows through the cold air the entire way, and it reaches the ground still as snow. That's your classic all-snow winter storm. When you zoom out and look at the big picture, there's a real method to the madness of winter precipitation. Instead of being 4 totally different things, rain, freezing rain, sleet, and snow, all sit on a spectrum, controlled mainly by one thing: the depth and position of the relatively warm above freezing layer in the atmosphere. Change the thickness of that warm layer and you slide along the spectrum. Deep warm layer to the ground, you get rain. Warm layer above a shallow cold surface layer, you get freezing rain. Shallow warm layer above a deeper cold layer, you get sleet. No warm layer at all and it's below freezing the entire way, you get snow. Both freezing rain and sleet are less common than pure rain or pure snow because they require a very specific vertical structure of warm and cold air. The warm layer has to be just the right depth and at the right height. The cold layer above and below it have to line up just right. These mixed precipitation types often show up along a frontal boundary that's hovering right around 32 degrees Fahrenheit. Along those fronts, you can see transitions from rain to freezing rain to sleet and then to snow over relatively short distances. That's also where winter weather forecast gets especially tricky. Even if a meteorologist nails how much total liquid water will fall, being just a little off on the depth of that warm layer can change everything. Being off by just 1 or 2 degrees or by a small amount in the vertical temperature profile can mean the difference between 10 inches of snow and 1 inch of plain rain. Winter weather can be complicated, and unfortunately it's also a prime target for hype and clickbait. In my next video, I'm going to share 5 red flags to watch for when you're deciding whether a winter forecast can be trusted. If you want clear, science-based weather explanations without the drama, make sure you subscribe to Untamed Skies turn on notifications, and let me know in the comments what kind of winter precipitation is most common where you live. Rain, snow, sleet, or freezing rain. Thanks for watching, and I'll see you in the next one.